Programming is facing a massive AI problem, and most people don't see it yet. And no, I'm not talking about AI stealing your coding job. That whole panic, massively overblown, and we'll get into why. The real crisis is how we're not effectively using these powerful new AI tools. We're fumbling the human-machine teamwork. Luckily, there's a checklist for this. We can look to a proven technique from aviation, a field that already wrestled with advanced automation. Aviation can show us how to integrate AI safely and unlock its true potential in programming, instead of just stumbling into digital disasters. Hi, I'm Christopher, and today we're diving into the AI-human interaction crisis in programming and how we can fix it. If you've been paying attention to the headlines recently, you've probably heard that the major problem facing programmers is that they'll be replaced by AI. And it's no wonder this idea gains traction when barely technical executives are sold a seductive but fundamentally flawed dream. Who wouldn't be tempted, though? Imagine the pitch. Get rid of that high-cost temperamental human capital and replace it with reliable and efficient machines. Code on demand, 24/7, no sick days, no stock options. It sounds like a miracle if your main view of software development is a stubbornly persistent expense line. This vision is aggressively pushed by a certain breed of consultant and, let's be frank, some incredibly influential podcasts that seem to have a direct line to the executive suite. They paint vivid pictures of a future where human developers are simply swapped out for compliant AI. It's a compelling narrative for anyone under pressure to deliver immediate, dramatic cost savings. The thing is, though, this thinking is foolish and short-sighted. The pressure for quick, quarterly wins, which make AI promises irresistible, will backfire. Cut headcount now, point to a new AI tool, and voila, instant perceived efficiency. But software, real, robust, valuable software, isn't built on short-term hacks. Relying on AI without expert human oversight isn't a magic bullet, it's technical debt. And AI? That's the subprime high-interest credit card of technical debt. Poorly managed reliance on AI will result in unmaintainable code, subtle but critical flaws generated without human understanding, and the atrophying of critical domain knowledge and skills. That bill will come due with compound interest. And paying off that bill? Well, that requires even more skilled, and yes, expensive, human expertise. It's like any fad. Remember the remote work revolution from a few years ago? The whiplash of the subsequent return to office mandate? Or frankly, any number of management fads from the past decades that promised easy shortcuts only to discover that the complexity was, well, complex. Programming isn't the only field that's undergone a massive transformation towards automation. Consider commercial aviation. Almost every commercial airplane at your local airport contains enough automation to fly itself from takeoff to touchdown. Many can even do an automatic landing in near-zero visibility. There are even some light aircraft that can perform an automatic emergency descent and landing if the pilot becomes incapacitated. In fact, just about the only thing these planes can't do on their own is drive around on the taxiway. The flying itself, though, it's all highly automated. But the crew in the front office, the pilots in the cockpit, they're still earning hundreds of thousands of dollars a year, many well over $500,000, and their ranks have only expanded significantly since the 60s. So why didn't airline pilots get replaced by an automated voice and a computer system? If airlines could pocket those salaries, believe me they would, public perception be damned. The answer to this question is crucial for us in programming. Like crafting complex software, flying is a dynamic and high-stakes environment. The routine stuff, keeping the plane straight and level, even navigating complex arrival procedures in zero visibility, that's not the core reason we still have pilots. Instead, pilots now manage the automation and bring the experienced human judgment in the loop. Pilots provide the flexibility, understanding, and critical decision-making that current machines simply can't replicate when things go off script. They're the ultimate systems administrators and troubleshooters for a very complex flying computer. It wasn't always this way. In the early jet age, the captain was often portrayed as a sky god, those stoic, all-knowing figures from 60s movies. The hierarchy was rigid.
Son, put your hands on your head. I don't want to see you move before we get to 2,000 feet, or I'm going to blow your brains out.
That mindset was real, and they expected him to get the coffee too. But as autopilots, GPS, and other advanced systems became more integrated, the job had to change. Pilots replaced by automation? That fear has been around for decades, just like we hear in programming today. And some roles did disappear. Remember the flight engineer? The fellow who sat behind the pilots managing a wall of gauges and systems? That guy is gone now and has been for many years. But why? Because the flight engineer focused on monitoring and adjusting known parameters. Tasks a computer could, and now does, perform continuously and far more accurately than a human. A modern airliner has a tireless team of digital flight engineers monitoring every parameter in every moment. The pilot role evolved. It shifted from primarily manual control to system management, from solitary command to team coordination, both with other humans and the machine. As automation in aviation advanced, planes became more capable, flying became safer and much, much cheaper. Pilot ranks and salaries even continued to expand. But this progress wasn't a straight line. More sophisticated automation brought new challenges. While allowing pilots to operate in tougher conditions, the very complexity of these new systems led to numerous disasters. It was not just old dogs who couldn't learn new tricks. Highly competent crews could find themselves fatally behind their digital counterparts. The advanced systems demanded a new level of teamwork, not just between humans, but between humans and the machines. Raw flying skills, still vital, were no longer enough. Managing the automation became just as critical. Aviation history has too many sad examples of this. For example, in 2013, UPS Flight 1354 had a capable crew in a modern, highly automated aircraft. Yet a lack of effective coordination and a failure to understand what their automated systems were actually doing during a critical phase of flight led them to crash short of the runway. It's just one of the many tragic reminders that automation, improperly managed, creates more problems than it solves. As these automation-related incidents piled up in the aviation industry, it realized that something had to change, that simply adding more tech was not the answer. They needed to change how crews interacted with that tech and with each other. Their solution was a revolutionary training philosophy called cockpit resource management, later renamed to crew resource management, or just CRM. While CRM covers a lot of ground on interpersonal skills, the core ideas that are vital for us in programming are: number one, build an accurate mental model. Continuously understanding what the automation is doing, what it's supposed to be doing, and what it will do next is building a mental model. This is often described as being mentally ahead, knowing what you expect things to do next, where the airplane is going to be in 30 seconds. Number two, break the error chain. Recognizing small deviations or misunderstandings early and intervening before they can cascade into bigger problems is breaking the error chain. This often involves clear communication and cross-checking, as well as taking meaningful action when things don't go as planned. Number three, effective decision-making with automation. With automation, knowing when to use the automation, when to override, and how to manage its limitations and potential failure modes is as important as anything else. And the incredible thing, these 3 CRM values, they worked. They dramatically improved aviation safety, even as aircraft became exponentially more complex. It transformed the cockpit from a place of rigid hierarchy to one of collaborative problem solving with sophisticated machines. Just as aviation needed a new framework in the age of automation, we in the software world urgently need a similar set of principles for effective AI. Let's adapt the concept and even the spirit of the name. We'll call our approach coding resource management, which also conveniently yields the acronym CRM. But for us, it's all about coding. What would programming CRM look like? It means adapting those core aviation tenets directly to our craft. First, build an accurate mental model. In aviation, it's about pilots knowing what their automation is doing and predicting its next move. In programming, it's about developers understanding their AI coding assistants. This isn't merely knowing prompt syntax. It means grasping the AI's likely failure modes, its common biases, and its strengths and weaknesses. If you ask an AI to generate a complex algorithm, do you understand the edge cases it might miss? If it generates a unit test, can you anticipate which assertions it will nail and which crucial ones it might overlook? You need to be mentally ahead of your AI, verifying its output against your deeper mental model. And yes, this means that a strong understanding of core fundamental concepts and knowledge doesn't fade when programming with AI, but actually becomes more important. Second, break the error chain. Modern flight training teaches pilots to catch small errors before they cascade. And AI coding demands the same vigilance from programmers. An AI's mistake, a subtly flawed piece of logic, an insecure code snippet, or a poorly optimized query might not be immediately obvious. Yet if not caught early in the process, it will propagate or even make it into production, leading to critical and expensive failures. Remember, if a user's data leaks because the AI made a mistake, the regulators won't find the AI, they'll find you. Finally, effective decision-making with AI. Knowing when to rely on automation and when to confidently take manual control is a key element of working with advanced systems. Coding resource management is about making smart choices, deciding how to use AI and when to guide things by hand. An AI coding assistant is the perfect tool for boilerplate code, generating test data, or refactoring a simple function. In fact, a programmer would be foolish not to embrace such tools. Yet for advanced design, the amount of prompting necessary to express the idea to the AI is far more work than simply writing the data structures, and often introduces subtle inconsistencies. Code is a great specification, probably the best specification. Don't hesitate to write some code in order to guide the AI. Adopting CRM in programming isn't just about damage control or avoiding bugs. It's about unlocking the full potential of these incredible tools. Developers can write better software more quickly when they understand how to partner effectively with AI. With AI, developers can create things that simply weren't viable when written solely by hand. Without this understanding, without this essential framework for AI and human collaboration, well, without these techniques, AI is just a source of new and inventive ways to make the same old mistakes, but on a much more painful and fast scale. This means we should make AI interaction and operations a key part of our coding skill set. We have to develop that mental model of what AI is doing and its limitations. We must stay ahead of it with clear design outlines and programs, guiding it effectively so it doesn't go wild. And critically, we should always remain vigilant and prepared for automation failures. If we embrace AI in programming, it doesn't program for us. Sure, it might spit out unit tests or function bodies, but these aren't the real value items. Letting the automation handle these rote tasks does not reduce our existing workload. It massively increases the horizon of what's possible by allowing us to think and dream up grand possibilities. The current round of layoffs using AI as an excuse are going to look pretty stupid before too long. AI is not going to replace programming. It's going to shift some of the key focus areas, and in some cases, make even more jobs. So if you're a programmer, where does that leave you? Well, ask yourself, am I a flight engineer or a captain? If you're a flight engineer, maybe someone who only tweaks CSS colors or doesn't have a grasp of the fundamentals, then there's probably real risks from AI. It's a great time to study up on the fundamentals of software engineering and programming. These core concepts are evergreen and will serve you well in the future and lead to a solid transition to the AI programming revolution that's underway. If you're a captain, then embrace the AI revolution. This is your mandate to lead using the principles of coding resource management. There's nothing noble about hand-flying straight and level flight for hours on end, and there's no extra points for writing all your tests by hand. Step up to the plate. Apply your deep knowledge to continuously refine that accurate mental model of what the AI is doing and where it excels. Exercise effective decision-making to strategically deploy these powerful new tools, knowing when to guide, when to delegate, and when to intervene. And foster the collaborative environment essential to breaking any error chain early, especially when working with complex AI-generated code. Use the automation to ship more, faster, and to tackle challenges previously out of reach. But also, get more collaborative and humble. I get it. You can reverse a tree in brainfuck, but that's not going to help you guide a group working with an AI that can spit out 25,000 lines in a day. The do-it-all single programmer mental model isn't going to help you stay ahead. Instead, embrace solid decision-making and the ability to guide the system where you want it to end up, instead of making each change yourself. So, put on your aviators, step forward, and enjoy programming, now with more, better automation, managed with skill, foresight, and a competent resource management commitment. Oh, and if you're a co-pilot, well, welcome on board. My cockpit is a collaborative environment, and I appreciate your input. Study hard and you'll upgrade to captain one day soon. Also, I take my coffee black with just a touch of milk.